In this session, we will present the UCT Fluid Solution Pipe and Tube Fitting Line. Our fitting line consists of 7 groups of products. On our compression tube fittings, we have the Let Lock, which is a double compression tube fitting. The One Lock, which is a single ferrule fitting. Pipeline fittings range of connectors cover all the threads fittings like NPT, BSPT, BSPP, etc. Weld line, which is instrument weld fittings. 3-piece tube assembly for the flare SAE 37 degrees. UH line for ultra vacuum fittings. Hamlet flange adapters. The Let Lock compression tube fitting. These fittings are available in tube sizes from 1/16 to 2 inches and with the parallel sizes in millimeters, 2 millimeters to 50 millimeters. To ensure safety, the fittings have consistent gaugeability on the initial installation. The fittings are easy to remake. They have a wide variety of materials and different configurations, and above all, they have proven reliability, improving performance. One Lock is a single ferrule fitting. The One Lock tube fittings are composed of 3 parts: the body, the nut, and a single ferrule with precision engineering and machining. The Hamlet One Lock is designed to provide a leak-tight and secure connection that can withstand high-pressure vibration and to function in vacuum applications. The One Lock parts are identical to the Let Lock parts, besides the single ferrule that functions for leak-proof and mechanical grip to secure the fitting. Instrument pipe fittings. These fittings come with size range of 1/16 up to 2 inches. Various thread types on NPT, BSPT, BSPP, and SAE following the standard. All the pipe threads meet the design and pressure requirements of the piping code ASME and ANSI B31.3. It also applies to Section 8 of the ASME boiler and the pressure vessel code. 3-piece tube assembly SAE 37 degree flare. The flare fitting technology began in the 1920s for hydraulic systems. They were adopted by Air Corps, a part of the U.S. Army. The male and female end has a thread and a 37-degree cone taper. The seal takes place between the male taper and the inside diameter of the tapered gland, or the flared tubing. Flared connections offer a high degree of long-term reliability, and for this reason are often implemented in critical mission and inaccessible locations. Hamlet UH line. This line is designed for ultra-vacuum systems. It has a full range of sizes of 1/4 to 1 inch. Maximal temperature for 242 degrees Celsius. Designed for ultra-vacuum systems on a level of 10-6 torr. Assembly parts helium leak tested to 4 × 10-9 standard cubic centimeters per second. Metal parts are made of 3/16 stainless steel. O-rings made from fluorocarbon, FKM. The performance is maintained through repeated disconnects. Using the knurled nut, which enables finger-tight assembly, it is very easy to use, to remove, and to reposition in the system. These fittings come with different shapes, such as angle, straight, and T, and are available as end connections for the Hamlet valves line as ball valve, needle valve, diaphragm valve, filter, check valve. Weld fittings provide strength and reliability needed to maintain fluid system efficiency and safety. Weld fittings are available in a variety of sizes, shapes, and materials for ultra-high purity, specially cleaned, and industrial applications. Full range of sizes from 1/4 inch to 1 inch. Stainless steel fittings. Material is stainless steel 316L. Straight. ASTM A479, ASTM A276, and DIN EN 10272. Shaped. ASTM A182 and DIN EN 10122-5. Flange to Let Lock tube fitting adapters reduce potential system leak points with a threadless weldless transition from flanged piping systems to tubing systems. A full range of sealing faces are available. Threadless weldless transition from flanged piping systems to tubing systems. ASME B16.5, nominal flange sizes from NPS 1/2 to 2 inches. Pressure class ratings from 150 to 2,500. DIN EN 1092-1. Nominal flange sizes from DN 15 to 50. Pressure class ratings from PN 40 to 320. JIS B2220. Nominal flange sizes from DN 15 to 50. Pressure class ratings from 10 to 63K. One-piece integrally machined forged body. Full range of sizes from 1/16 of an inch to 2 inches. Material: 316 alloy 400, alloy C-276 sizes. ANSI flange complies up to class 2500. In the old method, each connection is threaded, which requires numerous fittings. The system is not flexible or easy to install, and service connections are unsmooth inside. Pockets obstruct flow. In the modern method, bendable tubing requires fewer fittings, and no threading is required. It is system light and compact, easy to install and service, with no internal pockets or obstructions to free flow. Major advantages of tubing over piping systems. 1. Bending quality. Tubing has strong but relatively thinner walls, is easy to bend. Tube fabrication is simple. 2. Greater strength. Tubing is stronger as no threads are required for connection. No weakened sections from reduction of wall thickness by threading. Letlock structure. The Letlock tube fitting is a flareless mechanical grip-type fitting consisting of a body, nut, front ferrule, and back ferrule. It is an industry-leading two-ferrule mechanical grip-type tube fitting and has set the standard for performance and reliability. Letlock assembly. One of the unique abilities of this proven design is the ability to seal and hold on a wide variety of tubing materials, wall thickness, and hardness. Because the amount of back ferrule grip is determined by the tube's resistance to front ferrule action, the grip is much tighter when the heavy wall tubing is encountered. This is an important design feature because heavy wall tubing is often used in service conditions such as high pressure or other unusual stresses, vibration, pulsation, or shock. Thus, the Letlock tube fitting, by design, grips much more securely on heavy wall tubings than it does on a thin wall tubing used for more moderate surface. Letlock assembly. Gather the required tools and check that they are clean and in good working condition. 1. Tube cutter. 2. Tube deburring tool. 3. Inspection gauges. 4. Standard wrenches. The second step, cutting. To attain a leak-free connection, cut the tubing. Square with a good quality tube cutter with a wheel designed for the tubing material. Mark the tubing at the desired location 360 degrees around the tubing circumference using non-scratching marking device such as a marker or wax pencil. Align the cutter around the marked place to be cut and tighten over the tube so that the wheel firmly touches the outside diameter, OD, of the tubing. Do not over-tighten to tubing cutter as damage to the tool or the tubing may occur. Rotate the cutter around the pipe, following the score and tightening 1/8 of a turn every 2 rotations until the wheel penetrates the inside diameter, ID, of the tubing. Do not try to reduce the time of cutting by over-tightening the wheel. This can force the tubing out of round or will harden the tube OD. Third step, tube deburring. Gloves and eye protection are strongly recommended to prevent injury. The cutting wheel on a tube cutter does not remove material, but instead displaces it, leaving a raised area at the cut and often pushing material into the ID. Removal of this material is essential to proper fitting performance and system integrity. To deburr the OD of the tubing, firmly insert the tubing into the OD side of the tool and rotate the tubing evenly until all burrs are removed. A slight chamfer on the end of the tubing is acceptable. To deburr the ID of the tubing, firmly insert the tubing into the ID side of the tool and rotate the tubing evenly until all burrs are removed. A slight internal chamfer on the end of the tubing is acceptable. Remove metal chips from inside the tube. Wipe the inside and outside of the deburred tube end with a clean rag. The fourth step, installing let-lock fitting. Let-lock fittings are supplied assembled and finger-tight. Insert the tubing into the let-lock fitting. Check that the tube rests firmly on the fitting shoulder and that the nut is finger-tight. Mark the nut at the 3 o'clock position. For all fittings 1/4 to 6 millimeters and larger, tighten the nut 1/4 turn so that the mark is now at the 6 o'clock position. For all fittings smaller than 3/16 to 4 millimeter, only 3/4 of a turn past finger tight is required to assemble. Further tightening may damage the fitting or restrict flow through the tubing. The fifth step, inspection. After initial assembly of the fitting, use an inspection gauge to ensure that the full 1/4 turns have been achieved. Insert the correct gauge between nut and body. If the gauge fits into the gap, the fitting has not been sufficiently tightened. If the gauge cannot enter the gap, then you are assured the fitting is sufficiently tightened. Do not use the gauge for reassembled fitting. Let-lock reassembly instructions. One of the big advantages of let-lock tube fittings is that they can be assembled, disassembled, and reassembled many times without compromising performance. Prior to disassembling any fitting, isolate and completely depressurize the system. Never bleed system pressure by loosening a fitting. Mark the position of the nut in relation to the fitting body and mark the tube at the end of the nut. These marks ensure that we can return the nut to the original position later during reassembly. Never bleed system pressure by loosening a fitting. Mark the position of the nut in relation to the fitting body and mark the tube at the end of the nut. These marks ensure that we can return the nut to the original position later during reassembly. Disassemble the nut. Insert tube with pre-assembled ferrules into the fitting body until front ferrule rests firmly in the fitting body. Hold fitting body firmly with a wrench or vise and rotate the nut finger tight. Using a wrench, return the nut to the original assembled position so that the marks on nut and body align. Tighten slightly with a wrench until a sharp rise in torque is felt, around 1 degree to 2 degrees. All pressure ratings are based on minimum wall and maximum OD within the applicable ASTM tubing specifications. A conservative rating is thus established based on worst-case conditions with factor 4. Using the tubing not according to ASTM specifications may cause some changes from the pressure ratings shown in the tables. Tube fitting advantage. The development of the let-lock tube fitting is the result of our proven design, manufacturing excellence, and superior raw materials. These advantages, along with the care of our associates, quality culture, and unrivaled experience, all work together to ensure that every fitting meets our customers' highest expectations for safety and dependability. Excellence in manufacturing. The radial compressive stress generated during processing can significantly improve the fatigue strength and torsional strength of the parts to upgrade the performance of our threads. The high number of remakes, less maintenance, and replacement results in lower total cost of ownership. Radius junction processing technology within elbows provides smooth flow path to reduce flow resistance and eliminate entrapment zones, which makes it easier for pipeline internal cleaning. The hardening process of back ferrule surface include 1. The ferrule appears like a simple product, but is perhaps the most critical component in compression tube fittings. It is highly engineered and, to function properly, requires considerable design, metallurgy, and production expertise. Not all products on the market meet these stringent requirements. For instance, the ferrule must deform elastically and plastically, precisely during fitting assembly, to properly grip and seal the tubing. Its front edge must be harder than the tubing to grip and seal through surface scratches and defects. But if the entire ferrule is too hard, it may not deform properly. Therefore, only the gripping edge of the ferrule is hardened, while the rest has different, tightly controlled mechanical properties. Also, the hardening process must not comprise stainless steel's corrosion resistance. And finally, production processes must consistently turn out defect-free ferrules that hold tight tolerances and maintain metallurgical specifications. 2. Hardening is done on all back ferrule surfaces. 3. UCT Fluid Solutions hardening treatment does not apply a coating on the surface, but produces a pure carbon-rich diffusion layer from the surface inwards, with excellent toughness and no risk of peeling or delamination. This treatment increases the surface hardness to 1000 divided by 1200 HV 0.05 and enhances the corrosion resistance of AISI 316. 4. UCT Fluid Solutions hardening treatment is a low-temperature process causing minimal changes to geometry and shape. 5. The hardening treatment is diffusion of large quantities of carbon into the surface without the formation of chromium carbides. The properties of UCT Fluid Solutions hardening of back ferrules enhances corrosive resistance, has no change in the geometry or surface roughness, prevents galling, and sensitization. In addition, no other elements are added, only carbon. UCT Fluid Solutions orders tailor-made 316 stainless steel material, which complies with factory standards to bring better mechanical performance to exceed ASTM and ASME. 316 stainless steel material composition comparison between UCT Fluid Solutions factory standard and ASTM A479 to control carbon, chromium, nickel content of UCT Fluid Solution standards are all more stringent than ASTM A479. The emphasis on composition control is because chromium. Among alloying elements of austenitic stainless steel, chromium is the most important and decisive element, mainly reflected in corrosion resistance. Nickel. It is the main alloying element of austenitic stainless steel. Its main function is to form and stabilize austenite so that stainless steel can be a fully austenitic structure. Increasing nickel content not only can improve the stainless steel mechanical properties like strength, low temperature resistance, and welding performance, etc., but it also improves corrosion resistance properties such as high temperature oxidation resistance and hydrogen embrittlement resistance. Carbon. Carbon and chromium can form high chromium carbide that leads to chromium depletion and lowering the corrosion resistance of the steel. All fittings are marked to ensure the consistency and traceability of our materials. We add a special mark to detect the millimetric sizes of the bodies bars and forgings. Marking advantages. Material traceability on all the fittings items, including the ferrules. The marking is done by a CNC machine to assure no mistakes during the process. Since it was established, UCT Fluid Solutions has applied sound quality control standards in all activities. We are also ISO 9001-2015 certified. Our products have been certified by different industry authorities and third-party inspection institutions in various countries to obtain a variety of certificates, including TA Luft, ABS, ASTM F1387, CRN, PED certificates. ASTM F1387 certificates for tube fittings and interchangeability and interminability with swage lock, including raw material composition. Training and technical support. Supporting customers with hands-on training, with safe practices and proper installation are imperative to the performance of the Letlock tube fitting, especially in critical applications. In addition, we supply custom-made fittings according to the customer's request. Alloys and combating corrosion. The global search for oil and gas, power generation, and chemical production has become more challenging due to corrosive production environments. Many of these cases often involve significant amounts of hydrogen sulfide, carbon dioxide, brine, or hazardous chemicals, among others, where it might lead to a fatal failure. In most cases, these situations could have been avoided by properly analyzing the specific operating parameters and using suitable materials. Why nickel alloys? Nickel and nickel alloy wire and strip exhibit high strength at high and low temperatures, toughness, corrosion resistance, controlled thermal expansion, workability, and excellent spring properties. Alloy 825, UNS designation N08825, is a nickel-iron-chromium alloy with molybdenum and copper additives. Alloy 825 provides exceptional resistance in many corrosive environments. Alloy 254 SMO6MO, UNS designation S31254, is an austenitic stainless steel combined of high molybdenum content, coupled with nickel, copper, high levels of chromium, molybdenum, and nitrogen, giving the alloy a superior resistance for pitting and crevice corrosion. Alloy 400 is also resistant to many forms of sulfuric and hydrochloric acids under reducing conditions, but shouldn't be the first choice for that. Alloy C-276 is a nickel-molybdenum-chromium alloy. Corrosion resistance in a wide range of aggressive media, resistant to general corrosion, stress corrosion cracking, pitting and crevice corrosion in a broad range of severe environments. Alloy 2507 has 25% chromium, 4% molybdenum, and 7% nickel. SS316 have 2 to 3% molybdenum. Good weldability and workability. Superior resistance to pitting and crevice corrosion than other austenitic stainless steel duo for high molybdenum percentage. Summary: outperforming. Value: excellence in manufacturing. High number of remakes, less maintenance and replacement, which results in lower total cost of ownership. Hardening of back ferrules. Letlock can be used in very corrosive areas. Robust product for long service life. Letlock material recipe. Long service life, wide range of possible applications and medias. Lower total cost of ownership due to the high corrosive resistance, which results in less frequent maintenance. Traceability by marking. Removes the risk of defect material batches mix. Remove customers' risk of non-controlled and non-traceable defected install base. Testing certifications and validations. High reliability. Saves a lot of qualification testing time and money.